So today I'm going to, discuss about an approach. Then Dimitri's presentation was excellent presentation, which has, given a deep insight into something you can use. I'm going to talk in terms of cyber forensics, and how you can use Python. In my opinion, again, while I work with many languages, I know that Python is probably the best language for working with cyber forensics. So this is what my topic of talk is: making your network ready for cyber forensics analysis. I'll try to finish this in around 10 minutes, and then we look at some code examples. Um, and we'll do it live. So quickly about myself. So I have been working in this industry for 23 plus years. I have a bunch of patents. I have also a book, Python for Cybersecurity cookbook, which I wrote last year. Doing pretty well. A lot of colleges have been using this as reference material. I have been doing a lot of research on cybersecurity and cyber forensics. That's my current area of research. This is my book. Please check this out. It's available everywhere. And all the code for this book is available in GitHub, completely free under MIT license. Please feel free to use it in whatever way you want. You don't have to give us anybody credit. If you want to use it, please go ahead and use it. It's really good in terms of getting you started with cybersecurity using Python. Now, quickly about this my company, Visimind Technology. Again, focus on cybersecurity and cyber forensics and consulting, especially vCISO consulting. And also I've been doing a lot of work on hyperscaling and distributed architecture. So that's about me and my company. Let's get into what is cyber forensics. So cyber forensics, as a term, it is very similar to forensics. When a crime is committed, the law enforcement folks have to find out how the crime was committed, and collect evidence, and that evidence can be used to prosecute criminals. In the same way, in case of cyber forensics, we collect evidence so that we can prosecute, or we have a hope to prosecute criminals, cyber criminals. And the main goal in this case is, now in case of forensics, we collect a lot of evidence, which are physical evidence, which can be fingerprint, which can be actual physical thing, something disruption. In case of cyber forensics, we however collect digital evidence. Now, what are digital evidence? We will talk about it. So in general, main functions of cyber forensics would include four things. First is collection of the evidence from the cybercrime scene. Second is preservation of the collected data. You need to preserve it because sometime it has to be used in a court of law to for all sort of proceedings and prosecution. Third is analysis, which is what cyber forensics expert would do. It can take days to weeks to months, based on the complexity of data collected. You could collect data from live system. You could collect data from dead system, like you got a hard disk which is not alive running, and you could actually dismantle it, open it, and collect, really retrieve data from the platter, from the magnetic media, and so on. And finally, we have documentation and presentation, where this entire analysis is presented to the court in the court of law, in a hope that it leads to some sort of prosecution. Now, what could constitute digital evidence? It could be anything which can be stored digitally. Everything we carry with us, desktop, laptops, smartphones, and whatnot. We also have a lot of system information, which we'll focus on today, in demo, where these information could include things like network information, running processes. If you have logged in users, if you have incoming connections from somewhere, local connection, remote connection, all those things would include system information. This is relevant for live system, not for system which is dead system. As in, if you got a machine which is switched off, then this is not really applicable. And then we have other information which is collected, which probably you will not probably think of this as evidence before, but these are also important to be collected. For example, cache, history of what you have done so far on your system, printer logs, because by the way, printers are used for printing things, confidential things, and you could see that what's going on there, firewall logs, and so on. Also, You could collect information for malware. Malware footprint is a small typo there. Malware footprint. So if you have malware which are installed on the system, you could collect that. So how do we make our network ready for cyber forensics? We're going to talk about that. So first thing is we need to log everything as in everything, whatever is possible, till the time it does not hamper the performance of the system. So of course, you could think of logging on the debug level, but that would probably increase the CPU consumption and resources. It takes up a lot of resources, a lot of IOPS and so on. So we would collect that, but there's a balance has to be maintained. We also enable audit logs to catch any file changes. We collect logs from all the firewalls, IDS, IPS, intrusion detection system, and intrusion protection systems. Uh, we also collect backup device configuration on periodic basis. So if there are backup devices and they have certain configuration that has to be collected, so that we need to make sure that nothing has changed. Um, the another important point is to create a baseline from time to time, which is a good baseline, which is a baseline which says that it's not compromised system, and you could you could actually compare this with the baseline to see if something has changed. We can collect information from SIM system. We can periodically archive logs, and we could also keep the network audit trail ready. So these are some of the things which we collect. I mean, of course, these 8 points would lead to collection of information from hundreds of sources. So for example, logs itself, if you start collecting information from logs, a Linux system, a Debian-based system or a Fedora-based system, any of these, uh, both families would have not less than 50, 60 logs which can be collected, or at least a part of that is collected after applying some filters. In the same way, all the network devices can play a big role in collection. Uh, Now, what can you do when you have changes in the critical file? So if the file is changed, and you know that file has changed because you have you are also monitoring the audit logs, then what you can do is you could actually say, fine, let me run a vulnerability scan or live packet capture to capture what's going on in the network, so that I can detect intrusions. I can detect if somebody is trying to do some scanning and things like that, right? So that all of these are linked together. So when you create a system which is ready for cyber forensics, that means that basically that the system is collecting evidence on an ongoing basis, and that evidence can be used to find out what happened in the network or in that specific system. Okay, so in the demo, what we would discuss, so there are a couple of things which I have listed down. So I'm going to cover the first three. So first is we'll check if the audit is enabled. So I basically written a very simple, very quick coding in an hour or so, and there I have written some very quick and dirty functions in Python which will do certain things to give you an idea. But in real life, you would have hundreds of such functions. In fact, I'm working on a project right now where we are trying to develop hundreds of such functions. We already have around 50, 60 ready with us. Again, this is right now not in open source. I mean, the one which I'm doing right now, which I'm showing going to show, I'll put that on GitHub. But the other project, which is not in open source right now, but sometime in the future, we'll probably make that also open source on the GitHub. So first thing we'll do is we'll check if the audit is enabled. If not, then it's failed. If it's enabled, it's pass. We also check if syslog is enabled. Now, syslog is most of you who are working on Linux or who are system administrator would know that syslog is one of the best ways to send messages to a central logging server from everywhere, and then that log can be used to create various things like timelines, create things like if you have intrusions, detect anomalies, and so on. Cron tab is another file which is in Linux, which is used to schedule jobs. So cron is around for very long, as long as I know, and when it's one of the best ways to run schedule jobs anytime, every few minutes, every few hours, in midnight, once in a month, and so on. So cron tab is also something which is used very, very often to do things. So what we want to check is if somebody has changed cron tab, and because of that, uh, somebody has scheduled something or removed some schedule, right? For example, I want to collect logs. I want to archive all the logs and push it somewhere in as a cron job, and somebody has removed that. Then that is a problem. And the fourth one is to find out if new RPMs are installed. So while people try to make things really complex, uh, in my opinion, collecting evidence is about uh, doing small things, very small things, and putting them together. A small security control, which is probably 5 lines of code, but if you have hundreds of such controls, that makes it like super powerful, and you can also pick and choose what you want in terms of collecting evidence. And once you run it as on a periodic basis, on ongoing basis, you have evidence collected, and it's ready. System is ready for cyber forensics. How I'm doing in terms of time. We will move to the demo. All the code for this demo will be available in GitHub. So I have a GitHub called Open Source Cybersecurity, and under which there will be a repo called XtremePython. I'll be probably pushing it sometime late night today. All right. So we'll move to demo for this. So is there a question? Are these libraries that were developed specifically for cyber forensics? Uh, so not really. So cyber forensics, uh, uh, the evidence collection on any system can be done without using very unique libraries. It can be done very simply by using simple Linux commands. Of course, there are libraries which can be used, but in Python, I have not come across any library for collecting forensic evidence. However, just like simple Python programming, if you are a good Python programmer, you should be able to write this yourself to collect evidence, or you could just use some of the open source code which we know we are going to put there, and then extend that to add your own evidence collection. I'll show you in the code and you will appreciate how easy it is. Let me move to my VM here, and I'll first explain the code in few minutes. So I have three functions in Python. And then first function, what does it do is let me just larger so that people can see it very well. So first function, what does it do? It checks if audit log is enabled. So audit log is enabled. It can be checked by using audit CTL. So uh, if you use command called audit CTL -L, so this basically tells me that I have audit log enabled, which is going to do the audit logging if something changes in password file, which means that whenever I add a new user, I delete a new existing user, it will automatically do audit log. So this audit CTL, which is the audit daemon, is watching this file and making sure that this any changes to this file is logged. So audit CTL. If you do man audit CTL. So this is a utility to assist controlling the kernel audit system. So Linux has an inbuilt audit system. If it's not, um, installed, you could always install this. On most of the Linux, it may be already been installed. If not, then you can just install it using yum on apt-get. Okay, that's the first one. The second, so this will basically what we'll do is we will look at both the pass and fail conditions. So first, it will check if there are audit logs which are audit rules which are enabled. If not, then this control is failed. Second one is check syslog status. So it also runs a command to check if a syslog is running, and then it will basically tell if the syslog is configured or not. If syslog is not configured, which means it is failed. And the third one is cron tab status, which will again run a command to check if the cron tab is running. So that's the current status. This will be cron tab, and that's about it. Now what we'll do is I'll run this program and see what happens. So if you see this, this is a simple way to, to check if your system is something has changed. So I see that here audit config for password found. So I have passed this as password file as the argument, and it's saying that audit is enabled for password file. This is what it's found. Second is syslog is running. So syslog configuration is failed. Nobody has tinkered with it. Now cron tab status is failed. The reason is so this is a command. This is a function which is checking if there are changes in the cron tab when it was last changed. And of course, I've done some changes because it fails. Now let me just do one thing quickly. So what I'll do is I will use audit CTL minus D, which will delete all the rules. Now, if I do a minus L, you don't see a rule. And at the same time, so right now it is running. I will probably stop this and see if or maybe I'll stop it next time. When I run this now, so now the first uh, check is failing, which means that audit CTL, there's no audit CTL. There is no audit log enabled right now. So which means that uh, your system is vulnerable. So what would a threat actor would do is threat actor, the first thing threat actor would do is if there are audit logs enabled, they will probably, disable it, which means that if you do any changes in the system, you can delete things, you can add new user, you could modify files and the logs, they will not be watched, and hence there will not be audit log generated, which means that if you are sending the audit logs as syslog or directly by using some file archival methods, you will not get the audit logs, which means that your threat actor is mostly, completely transparent from any detection. So that's how they do deception in this case. So that's one thing. Second thing is if I disable firewall, this syslog, if I stop it, and then this should again fail. And so, okay, so what is going on right now? So I think there's a bug in my system. So if I, no, it didn't stop. Okay. So it is inactive right now. So here, I think there's a small bug here. So basically, it should say that if it's inactive, it should say it's inactive. But you got the point. So ideally, this seems like a very simple way to check for forensic readiness. But this is an approach. This is not something which is a solution to a forensic check, collections, this cyber forensic collection for every evidence possible, right? But when this is not very interesting, when you add 100 of these controls and when you add a lot of conditions around it, when you make it foolproof in terms of all the conditions taken care of, then this becomes a forensic evidence collection tool. So we have been doing that for quite some time on another network where we run it as a cron job, and then it just keeps collecting the evidence and dumping it in some place. So it'll, at the end of it, it'll collect evidence from all the places, put it into a folder, and that folder is archived and shared somewhere. So next time, if there is a threat actor who does intrusion and we have a cyber attack happens in the network, uh, and then we have to tell to somebody that it has happened, we have to provide evidence, we have the evidence for the system mostly. So we could say that at least if we are collecting it, let's say once in a day also, you could at least say that by this time this was the case, and now this is the case. But you could do it more often. Some of these are not really resource intensive, which means that it can be done on a regular basis. So I would take a question. Should we not use sudo in place of directly logging as root? Yes, you're right, Rohit. So we could use sudo. It's just that I was not able to run it from directly from my VS Code because I ran it as my non-root user. But yeah, you should use sudo. and that is one of the best practices where um, you know the user which is running all these privileged command, they should only be able to run a few commands for which they are given permission. So you will only give permission for the commands which they are supposed to run. You will not give full root permission. Thanks a lot for that question.